Hello everyone and welcome back to Year 8 Mathematics. I'm Victor, and in Year 7 we graphed lines the slow way by generating a whole table of values. But mathematicians, especially me and my future students and a lot of other people, even the best ones, are extremely lazy. We want a faster way, that's for sure, and so we're going to be learning that faster way right here in this video. Today, we're learning how to look at an equation and draw that graph in 10 seconds flat, maybe 15 seconds, using this code, this equation right here, or expression right here, y equals mc mx plus c. Now, this right here, let me just circle around this, not really a circle, but you can think this one, I'm actually going to delete this, it looks horrible. So when you look at this, this is the most equation in coordinate geometry. Any straight line can be written in this format, period. The y and the x are just coordinates, but the m and the c are the secret code that tells you exactly what the line looks like. Let's look at m. M is the gradient and slope, and if you don't know how to calculate a gradient, can you please check my last video? We actually ran through how we can find this gradient over here. It is rise over run. So if you don't remember that, please check the last video. It's pretty easy. It'll tell you how steep the line is. The c, which is the constant number at the end, is the y-intercept. This is exactly where the line crosses the vertical y-axis. This is going to be your starting point. So m is the slope, m is the slope, c is the start. M is the slope, c is the start. The number on x here, slope or gradient, and the only number is our start right here. There's also like a whole other habit here I wrote here as well, but I'm just gonna zoom in here for you, everyone here, to see, right? So remember that rhythm. What we're gonna do is we are going to draw this. Now I've already drawn this. I'm sorry for that. I know I don't like drawing. May pre-drew this, of course, but I'll show you through how the process looks like, and I'll explain why we have this in the first place. So let's graph this. Y equals 2x minus 3. I'll write here as well, next here as well, just in case. Now I'm not going to use like a table of values, but I'm just going to use our first starting point, which is c. Where is our c? I've written it here. Every line can be written in this format, mx plus c. And so we can, if we were to directly map these values down here, you can see that m equals 2 and c equals minus 3. There you go. Right there. So we want to go to the y-axis, okay? We're going to find a -3, and we're going to mark a solid point. That is going to be our anchor point, our first point right here. I've done that, okay? Let's imagine that this is the only point that exists for now. Now, why we do this? Because it's the same as mapping values. When x equals 0, then y is going to equals to -3. That's the old way, but we're actually basing it all on c here, and we say, okay, where's c? C is -3. We go down here. What if c is 3? Then we go up here. Okay, so we found our first point. Let's go to the next point. We're trying to find m. We need to find m, the gradient. The number attached to x, as you can see right here, is 2. 2 is our gradient. Gradient is rise over run. 2 is a whole number. So how do we make it a fraction? Again, if you don't remember, rise over run, rise, run, fraction. This is a fraction, but 2 is 2 here is a whole number. We need to make this 2 in terms of fraction. So we can make this 2 as a fraction in terms of 2 divided by 1 or something like that. Okay? rise 2, run 1. We can think of rise 2, run 1 like this, because it's rise over run. So it means that the verticality difference in vertical terms should be 2, and difference in horizontal terms to the right will be 1. So we start at our anchor point. We add negative 3. We go up by 2 and go right by 1. We go up by 2 and go right by 1 because we have this gradient number that is 2. 2 is equal to 2 divided by 1. We're using this formula, this gradient here, to calculate where is going to be the position of our next point. And so we find that. We find that right here. We mark the dot. So we mark the dot for our first point if we go vertical. If we want to go to horizontal, we mark this dot right here. And there you have it. That is our next point. And so when you find these points, these 2 points right here, okay, don't just imagine this doesn't exist. You can easily take a ruler and draw this thing out from here, and there you will have your graph. Simple as that. You just graphed x equals 2 minus 3 in less than a minute. Not too hard. Okay. What about for example number 2? As you can see it down here. What about that? Are there any rules that we need to check with the second point? Okay, I mean, true, you gotta check with the second point, but I kind of want to go into the second example. Let's do that for the second example instead. So let's just delete everything here. Hope you kind of get it. If you don't, again, we do it over and over again. Math is about practice. So let's just delete this. For our next one, see if I have a table. No, we don't, so we just graph it on here. So let's just write it out. So if we were to write the original form, y equals mx plus c, again, if you look at here, I just need to swap the values together. I have m would be minus 1, 2, 3, c would be 4. Okay, now I'm starting with a positive number instead of a negative number. I just need to plot 4 up here. That will be my first point. So I put here, this is 4. This is going to be 0, 4, because it's 0 on the x-axis and 4 on the y-axis. Okay. Now, this is rise over run. Rise over run is minus 1 over 3. So it means that I need to move to the right 3 times and go down once. Simple as that. What if m was 1, 2, 3? Oh, it's simple. I need to go three times to the right and go up once. But I just need to go down here. So I just need to go down. So I go down. This is 3. I need to go to the right 3 times. So 1, 2, 3. And I found my next point. I found my next point already here. This is my second point in the second example. This one right here. And now, because I found 2 points, I will connect them with connect these 2 lines, 2 points together to form my second example line here. So I go through like this, very simply. It's gonna be pretty simple. Should be pretty simple. Should be pretty straightforward. Okay, that doesn't look the best. Let's just connect here. Okay, that's our line. Now it looks ugly. It doesn't look like something that's very polished, because if you look at the gradient itself, kind of looks awkward. Kind of looks bad anyways. So yeah. But can we check? Can we check for our second example right here? Oh, it looks kind of glitchy. Not glitchy anymore. Okay. So let's check with the second point. I want to check if 3, I want to check here. So if I'm gonna replace 3 into here, what will I get? So y equals 1 minus 1 over 3, multiply times 3 plus 4. I would get something like this will be minus 1 plus 4. This will be 3. So this is correct, because if x is 3, y is also 3, and this just shows that if x is 3, y is also 3 here as well. So it passes exactly 3 by 3. Okay, so I just mapped out the lines for you guys. It's not that hard. It's not that hard. Just look at C. Just look at C, of course, and then look at M. Like, what is M telling you? Is M telling you to move down or up? If it's negative, go down, and then move to the right like a few times according to the number down here. If it's not negative, then go up, and then move to the right. And then you have these 2 points, just draw them together. That's basically it. So yeah, plot the start, follow the gradient, and if you're in a test, I'm not in a test, but if you're in a test, always check with a second point to ensure your line is perfect, and I'll see you in the next video. Thanks for watching.